All of you seen the diagram? I'll minimize it because I need space to draw other things. Let's come. So what is the basic idea of this? The rotating rod should be replaced with a cell that one. So here, so there's a ring. Torque is needed. The resistor is connected about these fixed points. So here it will be, take this one. No, how to, which end will be positive, negative, anything? Which end of the rod? So B bar into the plane, B bar into plane, tangent. So this end will be positive. So here replace with a EMF. Angular velocity omega let it be. So the current I will flow like this. I think it's quite clear, no? Like previous discussion what we made. What is the EMF induced in the rod? B omega L square by 2. And what about current in the circuit? E by R. So current in the circuit will be B omega L square by 2R. What's happened to rod? What type of motion the rod will describe? Let's come for the Lenz's law. What is the cause? The angular velocity is the cause, no? Then how the angular motion will be opposed? There should be torque. From where torque will come? You look at the rotating rod now. It's in a magnetic field. A current I is flowing. So different parts of the rod will experience a force, and that ampere force will set up a torque about O. I'll show just in only on the rod. Let me show it. There's a point 2. Let me take a small element and how the current I is flowing like this. Let this be at a distance x, dx, B bar into the plane. There's a rod OA, and how the current is flowing in this direction. Tell me like this element, how the force will be on the B bar I. So the force will be in this direction. Will it set up any torque about O? Yes, a retarding torque. D tau should be equal to df into x. And what is df? B I x into dx. This is due to what? Due to induced current. So according to Lenz's law, the direction of induced current in the circuit should be such that it should oppose the cause. What is the cause? Angular velocity. How do I can oppose angular motion? By setting up a torque. And what direction the torque? Torque will act in this direction. Torque will act in this direction. And what this torque will do, will decrease angular velocity. So what happened to the angular velocity of the rod? Keeps on, decreases, and finally comes to rest. This is about torque due to induced current. Everywhere, almost around some 20 numericals are there, like how we had BIL, no? Similarly, the induced torque. Better directly remember this so that in exams, directly you can start from here. So let's calculate what is that induced torque here. So this should be equal to B. What is I from this equation? B omega L square by 2. This will be x dx. B square omega L square 2. I'll write it tau I, induced torque, no? So this should be equal to B square omega L square by 2, no? To R 0 to L. So what is the total induced torque should be? Tau I B square L to the power of 4 by 4R. This you call induced torque, or torque due to induced current. Just call induced torque, and how it will be directed opposite to angular velocity. Now, what is the question asked? Like I of t, no? current at any time t. For that, we don't know angular velocity, omega t. So how to bring angular velocity of the rod at any time t. So we'll enter into now the basics. So here that element what we assumed is like this. Dx, this will be df. If you want to just show one, what all we did. Let's come for the basic mathematics. Uh, how do this torque will act opposite to angular velocity? So let me write tau I. So this minus IO alpha should be equal to tau I. So this is m L square by 3 alpha b square L to power of 4 by 4r. Uh, do remember, because every time you can't calculate, torque due to induced current, immediately start begin and apply the rotational mechanics concept. Rotating rod replace with a cell, then look at the conditions, after that. So what you should do, what is that induced torque, directly write this and write down the Newton's laws of motion for rotational motion, then carry on with the mathematics. So what is further alpha, you can write d omega by dt, then integrate. Let me add a page. Actually, when you generalize, things will be very easy for you. Initially, you're now learning, you feel so many things you're learning. Maybe at the end of the chapter, you should feel that, okay, very few concepts are there here, not many. Let me write the mathematical part. Alpha, what you can write, d omega by dt. So d omega by dt minus m by 3. 1 L square get cancelled, so b square L square omega by 4r. So rest all everything, this will be 3 b square L square 4 mr minus dt. Angular to omega naught omega t. Omega equal to omega naught e to power of minus lambda t. What is that lambda? Lambda is all that terms. Similar thing, no? They're also exponentially decreasing. Then what is the expression for current? Substitute there. I is equal to, substitute that omega here, you'll get current also as a function of time. He's asking totally generated. What is the mechanism? H is equal to I square R dt 0 to infinity. Or this is equal to just what all rotational kinetic energy given to the rod at t equals 0, that only what pen finally consumed by the resistor. So this is what heat generated. There's a basic, I'm suggesting you that one. So those who are getting trouble, start with this one. See this, think on this 1 hour, 1 time, 2 time, 3 time. Once you get a basic, no, I'll now with the help of this 10, 15 numericals, I'll solve it. The background will be this one. Just see once. From here we have started. Now what you do in place of resistor, what will happen? We can bring capacitor, we'll bring a cell. Then instead of moving this constant given angle of t, I'll rotate with constant torque. All conditions will come. I will scroll down. I'll scroll down. Okay, let's take the next problem.